This is the last class meeting of CNET 50. You're here. Let me get down to the schedule. There's all the old videos. And here we are. This is 225. This is the last time. I'm not going to cover 13. I just want to cover Boss of the Sock because I think it's more important. NMM. Good. Yes, I'm glad you're there. Yeah, you tried to resend it. It was not there in the email. Anyway, so all I want to do today is show you the Boss of the Sock, and you got the rest of the semester to turn in stuff and take the final exam if you like. I don't have to turn in grades until May, but the sooner the better. And there will be no more Saturday classes, though. I won't be online or physically available on Saturday. So if you want to catch me, come to Monday through Thursday at 7:30 p.m. on Twitch or in room Science 37. So let's go. Right, and so put any questions in the chat if you have them. And when that is not happening, I was mentioned, so by the way, I might as well get on the tape what I did before. So if you look in the Canvas, here's the total points required. So it's 270 points to get an A. And several people have already got more than that just in Boss of the Sock, which I recommend. I think is the most important thing to do. The other stuff is all fine too. It all adds to the total, but these people are clearly getting an A just from the Boss of the Sock alone. All right, and so let's do some more Boss of the Sock. So here's one of my cloud servers. I have 2 cloud servers running, and they're going to keep running. And so let me get to the challenges. And I just want to pick up, here's Boss of the Sock. And I only did section 1 before, so I want to do section 2 and 3 and maybe some of section 4 today, level 2 and 3, just so people have good demonstrations. So the staging server IP, all right. So we want to find, now let me first, how to display Splunk on your own web server. You'll find that here. Let me bring it up. There's the project that shows you how to deploy it. So that's project module 3 and 4. And I'm putting it in the Twitch chat. Good? All right. Anyway, so we want to find the staging server IP, and so that's going to be, the easiest way to do that is to repeat a bit of the stuff from the first one. So the first thing was to find the traffic that went backwards to the web server. That was pretty much the main point of the first one. So you go to all time, and then we looked for HTTP data, which we can get from the data summary, source types, and as a student pointed out to me, you can search here for like HTTP. There's stream HTTP. So this will get me web data, and if I go down here and find the ones from the vulnerability scanner, they will have Acunetics in them. I shouldn't have to look too far to find them. And if I do find it too annoying to find them, I'm going to search for Acunetics. I guess I'll do that. I can put in the domain name. I'm really not Batman.com. That'll get web traffic going to our web server, because only the request to our web server will have that domain name in it. And most of the traffic to our web server is from the vulnerability scanner, so I really shouldn't have too much trouble finding some. There we are. Here's ones from the vulnerability scanner. So once you've found one of them, and I mentioned before, some students didn't know this, every time you're doing any kind of a capture the flag project or a real pen test or anything, you have to have a text document around and keep notes, because you're often going to need the information you find later. And so the main thing I want to record here is the web server IP. And that's going to be the destination of this scan traffic. So that will be destination IP right there. Okay, there's the destination IP. The scanner IP, I don't know if I'm going to need that, but it's handy together. It's going to be the source of this traffic, which will be this one here. All right. And now, the next thing to do was to find the traffic that went backwards. And for that, we want to take HTTP traffic, and we want to find the source IP, which is what we were just looking at. That's destination. CIP will do, client IP. All right. And we want the client IP to be equal to the web server IP. So that's this number here. All right, and then, of course, this traffic is not going to have that domain name in it. It'll be traffic where the web server is going out to some other domain. So I get rid of this I'mReallyNotBatman.com. All right, and if I run that, I should find the events that go backwards, where the web server acts as a client, and there should only be like 8 or 9 of those, and there they are. And these include downloading the malicious file, and I think that might have been it right there. Yep, get poison ivy coming for you, batman.jpg. That was the malicious file. And the domain name used for that was this one. There we are. That's the, this is the, I forget what they call it. This is the server hosting malicious image. Was here. All right. Let me just save this stuff. Okay. Now I think I've got enough starting information to begin to answer the question here. And so the first question here is, you found the staving server domain name. Find that server's IP address. Well, that we can find right in the same request here. This is a request going to that server to download something. So all I need is the destination IP of this. There's the destination MAC. Destination IP is here. And I can see it here. And I could make it look prettier by expanding it up here with the arrow. This thing would break it out into those separate items this way. Make it a little easier to read there. 22 ending in 114. So this is going to be, all right. There we go. Yeah, my projector's not working very well, but since there's nobody physically in the room, that's not as fatal as it could have been. So this is a server IP. All right. Then ending 114. All right. So those are some facts I've found. And if you go back to here, that was the first thing, find its IP address. All right. Now we got to find the domain names, other domain names on that server. And this is a good trick. All you have to do is Google the IP address. And if you have a well-known malicious address, servers that are used for malicious purposes often reuse the same information over and over. And sorry, I'm being held up because my projector has died again, so I can't see what I'm doing there. It's back now briefly. All right, so there's the server IP. I'm going to move it to this screen so it doesn't keep fading out on me. All right, 23. Let's get rid of this garbage. Okay, just Google that address, and you will get threat info. Here's a lot of threat info sources: threat, virus total, threat miner, rub, text, and so on. So choose any one of these. They all have pretty much the same information. They have historical information about that domain. And I'm waiting for the stupid projector to work again. It cuts out every few seconds. All right. And so here I should have other domains, records, threat miner, Wayne Corp, and the one I'm looking for is like Poison Ivy or something. It looks like I'm not going to find it there. Let's try a different source. Maybe this one. They all vary in the information they gather about malicious things. Get rid of this garbage. Okay. It's an Amazon server. Huh. These guys are telling me nothing but junk, no useful information. Let's try to find one that will give me useful information. Threat miner. That's probably likely too. And everybody has to pop up garbage in your way everywhere. All right. And it looks like they're not going to be nothing but ads and no actual information. Ah, here we go. No, that's the malware it hosted. And nothing about the domains. All right, I'm getting hosed. Let's try a few more. Virus total. There used to be a lot of good ones near the top. Now none of them seem to cough up the data quickly anymore. I'll open a few of these. Alien Vault used to be one of the good ones. I don't know if all the information is vanishing behind paywalls or what, or maybe it's just too old. But you used to be able to find this stuff pretty easy. Here we go. Here's a list of domains, including the malicious one. There it is, poisonivy.com. That's the malicious domain that they used, and that's the flag that we wanted to find here. So that's the LeetSpeak domain. All right. Now we want to find the brute force attack, and this is really quite interesting. So I'm going to stop showing this and go to demonstrate it here. I just want to open the instructions on the machine I can see, which is over here. Because the brute force attack is another really nice thing you learn about from Splunk. So here we start with all the HTTP events. There's a lot of them. And now I want to get the ones using the post method. So there's going to be HTTP method. I wonder if I can make this bigger. Might be able to. All right. Aha. Hello. All right. So HTTP method is here. All right. And the only HTTP method in this traffic is a get. And I got to wait for the stupid projector to stop being dead and coming back. Okay. It dies every few seconds. All right. So get. And then I want to change that to a post, which I have to wait a minute because the projector died again. All right, post. That gives me the post methods, and I do not want to restrict the client IP or the domain. I'm trying to find posts, although I think I want to, yep, I do want to put back in, I'm really not Batman. So let's see I want to see login attempts onto my web server, which are going to send a username and password by post, they almost always do, and I got to spell post better, and go to my server. So this should be all the HTTP post requests, and I should find 15,570 of them. So let's see if that works. Okay, 15,560. That's close enough. There's 10 missing for some reason, but I'm not going to worry about it. All right, these, like I say, these public servers, everybody has root. And students do sort of mess them up gradually. Anyway, all right, so I found the posts. Now I want to exclude the events from vulnerability scanner. So that's not Acunetics. And remember, you have to put this in capital, and then it ought to turn orange. I'm a little troubled why it didn't turn orange. I wonder if somehow this Splunk instance has somehow had the color highlighting turned off. It looks like it has. All these things should be showing colors. Some student must have found a way to turn that off. I'm not going to struggle with it. When I do that, I should be down to 431. Okay, I'm down to 441, which is a little weird. Okay, so 10 events seem to be missing from the database somehow, which is probably something else a student did. Let me see if my other Splunk server is less messed up. This one has got a few little things that have been modified that are annoying. Let's see if this one's better. Student 1. And I can restore it from backup. It'll just take 5 or 10 minutes. None of this is necessarily fatal, but that should have been it. Student 1, student 1. Maybe I spelled it wrong. All right. There, okay, good. Now, I just want to do the same query I did here. So I'm just going to copy the query and put it on this other server. Go to all time. Put in the same query and see if we get 431 or 441 or we get 431 here. Okay, seems to be the same on both servers, which is a little troubling, but I'll just keep going here. I got one working. All right. So anyway, now I want to examine the form data. And the easiest way to do that is to pipe to table of time, comma, form data. This is what, rather than seeing everything about every event like this, you can make a table with just certain information. And this is quite useful. This is a time-ordered display, although I'm not sure the time ordering is perfect if you don't click the letter here. And then you see the form it's sent to the server. And this is the data sent in the HTTP post request, which is going to be the login. So this is some kind of complicated stuff. I don't know what it is. Those are not logins. Down here, this is part of the brute force attack. Username is admin, 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 and a whole bunch of different passwords. Phantom, Williams, baby, and such. And I got to pause while the projector dies and comes back. Okay, and Dave and such. So that's the brute force attack. And there also are extra post events in here that are not part of the brute force attack, so I have to restrict it. So I'd like to say username equals admin. I think password equals might be good. Let's try adding password equals and see what happens. I just want to add it to the query here. I think I'll add admin too. I'm just trying to make sure I only get the events that are part of the brute force attack and not other events. So now now I'm down to 413 events. Username is admin, password is something, username is admin, password. Notice how this password's over there and this password's over here. This is quite useful. All of them, the password's over here, rock, cool, and everything. This one is different, a different layout, and we're going to see why it's different in a minute. It's also going to be the last one. If I look at the time, this one, the one that's funny was at 1448. The others are at 1445 and such. So you can see that the time sorting is not perfect. So I'm going to click this to sort by time, and that makes them going forward in time. I'm going to make them go backward in time because the last events are interesting. Here you can see really useful information about this attack. Okay, what happens is 50.8, 51.1, 51.1, 51.3, these are multiple guesses per second. This is an automated attack, trying guesses really fast, many times per second, until it found the right password, and then 2 or 3 minutes later, another person logs in with a different layout. And this is because you can tell this if you go back. If I don't use the table time form data for right now, I'm going to copy that, cut that into the clipboard, and run it this way. You can tell the automated attack from the real human logging in by the HTTP user agent, which will be here. Now you can see 412 are Python, which is the automated Python script doing the attack, and the last one is Mozilla. So if I click this one and look at the one from Mozilla, that's going to be, now I'm going to go back to that form again because I don't really care about this other information. All right. That's this one, admin Batman. So this is what's going on here. Now I'm going to remove this restriction of user agent. So now we know that the one that has a different layout with the password right there is someone coming in through a real browser, real Firefox browser, not through a script. So I'm going to get rid of the user agent now that I understand that. And now this query gives me the whole story of the brute force attack. This, if I sort by time again, because somehow the time sort is not very accurate, unless you do this. All right, this is the human logging in after the password was found. This is the automated attack. Many per guess going from here back to the beginning of time, trying a lot of passwords. And one thing that confused me is it did not find the right password right away here. So anyway, let me just point out some of the questions you can answer now. If I go to the challenges down here. All right. So now here's the brute force attack. They say find the IP address. You can easily find it there by looking at any of those queries. Now I want to find the executable file they uploaded to the server. So I need to start with this and look for EXEs. So let's go here. And I'm going to skip ahead to something else while we're over here. There's one down here that you can error. The first brute force password used you can easily find by sorting that data and finding the first one. And you can find the correct password, which is going to be the password that they used to log in later. And you can find the time interval between those two. And the easiest way to do that is to go back here. When they logged in manually, they used a password of Batman. So that means if I just add Batman to my criteria, I'll find only posts that contain the correct password. And those are going to be only two. This is the one where the human logged in later, and this is the one where the automated scanner found it. And I was surprised at first. I think when I did this thing live, I assumed that when the scanner scanned, the last guess would be the right one. But I think that's not actually true, because if you use a scanner like Hydra, it has many threads, and it's guessing like 10 times at a time, so it will guess many times even after it finds the right password. There'll be a bunch of incomplete requests in process. So anyway, that's the question that the CTF asks you, is to find the time it took between the time the scanner found the right password and the hacker logged in manually in a browser using that password. So anyway, that's more stuff to do with the brute force attack. And you can also find out how many passwords were attempted in the brute force attack by just counting those entries. So that's the brute force attack. And the next one is the uploaded executable file name. And for that, I'm going to try turning on this other projector here and see if we can get anything to work. Now, I've got some students in the room, and the fact that the projectors don't work is more of a problem. And, yeah. Oh, good. That might possibly work, although the odds are not good. Anyway, all right. So now let's find the executable file name. All we got to do is start with the post events in the Vuln scanner and look for file name extensions. So let me just take a look at the Twitch and see if there are questions coming in. Just can we export data from your Splunk and import them to our local Splunk? No, that is not easy to do at all, unfortunately. In fact, setting up this Splunk server requires going off the map and doing stuff where I had to find on blogs and stuff. You might, in principle, be able to do it, but I think with large data sets like this, it's extremely difficult. The only way I was able to do it was to get to how the data is actually stored and copy the files over. There's not an easy way to do it. You can find online instructions how to set up your own Boss of the SOC server. They are very difficult and cumbersome because the original Boss of the SOC used Splunk as the scoring engine in addition to hosting the data, and that turned out to be extremely clumsy. Anyway, so let's try to find the uploaded executable file name. So I do that by looking for just exe files in addition to this other stuff. So let's see if I can get my, if my projector will just keep working long enough. We have post requests not using the, wait a minute now, I think we do want to be going to this place. Events using, we're trying to, yeah, attacker uploaded to the server. All right, let's try adding exe. I think that's all we have to do. I want to get to here. All right, so I want not Acunetics. I don't want this password stuff. I want exe. All right, that would give me executables. And there's only 2 of them, so that's good. And let me go back to my hints. Search, all right, I found them. Now, what I'm trying to find, you've got to wait for the projector to come back to life here again. I won't be in this room again, thank God. If I have to keep using this room, I'll have to bring in my own projector. Anyway, so I want to find the name of the executable file, and it's just going to be somewhere in this method. In fact, the thing to do is to view the raw data, and then a student pointed this out to me, just use the browser search to search for exe. .exe, for example. There it is, right there, 3791.exe. That's the name of the executable that was uploaded to the server. And this is very common, by the way. If you take the pen testing course, 123, you'll find this is how you usually do it. There are online resources you get that has a list of known attacks, and you get just lists of them with numbers on them. So when you're using standard resources, you're often uploading files like that and running them on the server to exploit known vulnerabilities. All right, so that's it for section 2. And in section 3, we want to find this file's MD5 hash. And this is where I mentioned before, Sysmon is very useful. Sysmon is a Microsoft product, I think from sysinternals, and it improves the event logging. So instead of giving you hundreds of useless events for everything you do, it gives you a small number of events that actually mean something, like file downloaded, process created, process launched, things like that. And so if you look at Sysmon event IDs, it has a very small number of events and they're not very complicated. That's part of why it's so great. And so down here, there's going to be a list of sysmon event IDs. This is telling you how to install it. It's already there. Event 1 is creating a process. 2 is a process changing file creation time and network connection. And all we want here is process creation. Every time you run a program, it launches a process, and the person downloaded that executable, and then they ran it. So clearly, there's going to be an event ID 1 sysmon event related to that process. So if I go back to, and I don't want this stream data anymore, so I'm just going to get rid of all this. And I think for make things faster, I'll turn on sampling. In fact, I want to get to the search homepage. I get that by just hitting search up here. There we are. Now I can get the data summary. This is what I wanted. I'll wait for the data to appear, because I want to find the sysmon data, and this is an easy way to get the sysmon data. Okay, now the data has appeared. I can hit the summary, and then go to source types, and I can search for sysmon. All right, there it is. And you see it has this silly long name, but that's the name for sysmon data. So now I'm getting the sysmon events, and now I got to go to all time. Well, actually, I think I'll, just to be fast, I'm going to turn on some sampling even now, and now go to all time. All right, and now I get 500, which is, I only get a few events, but it didn't take long, and now I can find the event ID, which is right here. And I can see these very small number of values, and 1 is the one I want, which is even not the most common one, so that's even handier. So event ID 1 should be process creation events. Now I just turn off the sampling. And here's all the process creation events, of which there are only 49. And now I want that file name, which I think I have in my clipboard, 3791.exe. Those will be process creations that reference that event. And you might expect only 1, but there are a few of them. Let's go back to the list whenever my stupid, worthless projector comes back up. Okay. All right. Reminds me of the podcast I do, a professional podcast. They had a similar thing where every minute or so it would freeze up for like 5 seconds and I would miss part of the conversation. It's fairly common that you get technology like this that just dies every few seconds. Anyway, so here there will be, here's process creation. And see, here's a SHA-1, and I think there's an MD5 hash in there too. SHA-256, some of them have an MD5 hash. And so this was actually launching that process, cmd.exe, but there are others. So if I go down here and I look, there's MD5. 3 of them contain an MD5 hash in the event. And so one way to find the answer is to just try these until you find out which one works. 3 of them are the same and 2 are different. In fact, exactly telling which one launched that process is a little complicated, as you can see. And the way to see that is to get rid of this garbage, get down to the details here. All right, you can find, like, there's a command line is here, and then I think there's something called parent command line. Yeah, and so those are the 2 things that matter. So in fact, it might be worth, if you just look at command line and parent command line, you'll see, here's the command line. And so logically, you would think that the hash of this process would be here, when the command line was that, and these other ones are things that were launched to prepare the environment, and that might be right, although I remember when I did this, it turned out to be one I didn't quite expect from this. So I'm not entirely sure what part of this completely determines the process, but anyway, that's close enough to find the flag. And that's as well as I ever got at completely understanding exactly how to get the hash here. And we've talked about the brute force and the time interval and number of passwords. So that's it for level 3. And let me talk about the ransomware attack a bit. I may not do all of these, but this is very fun because, of course, ransomware is really popular these days. So the first thing they ask, this is apparently going to be the origin of it, this guy's desktop machine. So they want to find the IP address to this machine. So what you do is start with just the name, find an event including that name. This is how I'm doing it, which, like I say, this is not the best practice at Splunk to just put words in here. Specifying a field will make it faster, but this is easier when you don't know what you're doing, which is me. So I find some events coming from that person. Now I want to restrict it. Let me get my hints over here. All right, I want to restrict it to events. I'll look at the source field. So how many people are sending data, including the name of this desktop machine that I'm interested in? I should be able to make this bigger. Oops, not that one. This one. There. So the source, got to wait for the worthless projector to come back. Okay. This, that's right, it always dies, and then it dies again. All right. And I'm looking for source. Well, there's source IP. I guess that'll do. Thought they were supporting source field, but anyway, source IP. Well, here's the IP address. I'm looking for the IP address of that machine. And here's events. Now, you might just assume that most events containing that name would come from that machine, and I think that's in fact right. But what would be better would be to look at stream sources where you know the protocol. And for that, we do want the source. I see. This is source IP. That's in the data. But source is a Splunk field. There. That's which event did it. And see, SMB is one, and LDAP is the main one. LDAP, Lightweight Directory Access Protocol, is the protocol Microsoft uses for login events. So if I use these, I will see the login events referring to that domain name. This is that endpoint logging in to the domain controller. And so I'm supposed to find events on a certain day, 24 August, and I have to wait for the worthless projector to die and come back a few times. And I'm going to look at events on that day and look at their IP addresses. So I want to restrict the time. Now here I've got August 10, and here on my timeline I got August 25. I think if I click this, yep, this is from the events. This will give me the right time range. If I click on that, that should implement it. Right now I'm down to 48. Okay. And now I'm going to look at the IP addresses. And they're all going to this one place. That was your destination IP. Let's see what I have for source IP. Source? No. There's destination IP. There's got it. There it is, source IP. SRC IP. That's why I didn't see it. Still don't see it. Maybe somebody selected it. There it is, source IP. All right. So this, I think, is it. The address ending in 100 is it, and the other end of that is the domain controller. And once again, I got it down to two choices, and I wasn't precise enough to understand exactly how to narrow it down further. You'd have to Google details of this protocol. So that's the IP address of this, this endpoint. This is the ransomware endpoint. This is the laptop client machine that was used to spread the ransomware event. All right, and now we're going to look at suricata signatures that detected Cerber. So if we look for Cerber, we're going to find it referenced many times. Cerber is a family of malware, and we look at the source type for suricata. So I just put in Cerber. And of course, you often do know this when you're doing a ransomware event because it pops up junk on the screen telling you to pay the ransom. So it's not subtle at all to tell which ransomware hit you or anything. So I just need to wait for the worthless projector to die and come back again. Okay, put this in and go back to all time. We'll see if that's true. We'll see if I find the right number of events here. I'm finding 21,596. That's what I wanted. Okay, now I examine the source field, which again is the Splunk field telling you where it came from. And we want suricata. All right, there's only 5 such events. So suricata is an intrusion detection system, and it detected this malware, sending network traffic it didn't like. And so now I want the suricata signature, which will be down here someplace, alert signature. There, you see there are 3 alert signatures, and one of them was different, and they wanted the ID. So they asked which ID had the least number of times, so you can find it there. All right, now I want to find where the suricata ransomware directed you to. What suricata does, what ransomware does, encrypts all your files, and then it opens a browser and goes to the ransomware page, or somehow pops up a ransomware page. So this one here, I find suricata alerts about onion domain lookup. So I'm going to go back to here. I'm looking at suricata. I'm going to get rid of Cerber. And actually, I can just put in onion probably. That'll probably do it. Let's see if that works. I'm only finding 2 of them. There are probably a lot more of them, so let me just get all the suricata alerts. Yeah, there's thousands of suricata alerts, but there's going to be like a description of the event here. I think event type. I've got a new process about onion domain lookup. There's going to be a suricata. Now, let's see. I'm not having any luck figuring out where it is. Let me see if there's any comments, by the way, in the Twitch. Good. Somebody tell them where to download stuff. All right, good. So this one is a hard one, and I've had several different processes. And each time I try to leave enough hints for me to do it again, I still can't do it even from my own hints. I can't figure out how to find suricata alerts about onion domain lookup. I think there is a suricata alert description or something here, which I'm not able to find now. This is the hard part. You're looking through all this long list of junk, trying to find the useful things. And it doesn't help that every few seconds I can't see it anymore. But this is the way real combat tends to go. I'm just waiting for the screen to come back. All right. Suricata alert. I am really not finding any suricata alert information. All right, I'm going to abandon that technique and try my older technique. I'll start with the suricata alerts about Cerber. It's not that the thing keeps changing. It's just this process is complicated, and it's very easy, especially when doing it live, to skip some step. All right, so now I've found 5 alerts about Cerber. Now, view them as raw text in time order. Okay, and I think they're already in time order. 1512, 1512. These 2 are at exactly the same time. This one is 1049. Yeah, the most recent one on top and the earlier ones below. Okay, I'm now viewing them in time order. Now find a time delay. This is the trick. Remember the brute force attack. There were many guesses per second and then a gap of 2 minutes before they came back. You can see the same pattern here. This is what ransomware does. It starts detecting some kind of Trojan about a ransomware at this time, 1049, then 1049, then 1049, then 11:15. So there's a 25-minute gap. What happens is you get infected and it picks up the thing coming in, then it runs for 25 minutes encrypting all your stuff, then it comes and pops up the ransom message. So this is when the attack was over, and those 25 minutes are when the stuff was being encrypted. Now, note the latest time. So what I want to do is they asked me to find out where it went after it was done encrypting. So I want to zero in at events at this time. So I do that by just getting within a few seconds of this time. And the easiest way to do that is to expand it so we can find the time. I guess I got to view it in some other view, maybe list. There we are. Now I can see the time here. I want to be within a few seconds of that time, and I have to wait for the worthless projector to die and come back, and then probably die and come back again. Yeah, all right. All right, so if I click this, it will now give me an option of being just within 5 seconds of that, and I'm going to just apply that. I highly recommend this procedure. What I've done before is actually try to use the state time range up here to carefully choose the time range, and then you have a serious problem with time zones. When I tried to teach this in a different time zone, it was off by an hour or 2, and that really threw people off. Using the GUI to restrict the time zone is better. So now I have only those 2 events. And now that I've found the time range when it was getting the ransom note, now I can look for search all events within that range. And then I say examine suricata events. So I'm going to first start with all events in that time range, which is a 5 or 10 second time range. I guess I got to put in a star to get it to do it. All right. Now I got to wait for this thing to die and come back. And die and come back again. All right, now I got 15,000 events. Now, if I look at, now I can go to, I want to find suricata events, so I'm going to go back to source here. And I thought there might be more than one kind of suricata event, but here they are. These are suricata events. All right? There are 50 suricata events in this time. And I want to look at DNS-related fields. So, DNS, our name and our type and so on. All right, here's various DNS fields. DNS ID, code, data, resource name. Here we go. There it is. This R name thing, our name, resource record name, this is what it's looking for, and that's the one I'm looking for. This is the one with Cerber in it. That is the domain name of the Onion domain, and it's not obvious like it is. The Onion domains are domains hidden behind the Tor network so that they're where criminals hide because you can't find out what country they're in, and usually they have domain names ending in .onion, but apparently there are other ones because this is another one that is an Onion domain even though it doesn't look like Onion. So anyway, that is the fully qualified domain name that went there. And I think the last thing I want to do is try to do this suspicious domain, and I think that'll be it for this demo. That's enough for one day. I want to find the suspicious domain visited by Web 8105 desk on 24 August. So I'm going to find suricata events on that day. So let me go to all time again. Well, while I'm here, I guess I'll just do it here. They wanted me to find suricata events on 24 August. And since we're right here, I can just fill this in. 00 colon 00 colon 00.000. Okay. And what, 23 colon 59 colon 59.999. That should be pretty much all day. All right. That would give me the right time range. And now I want suricata events, which is what I've got up here. All right, there should be 86,579 of them. So I got to wait for the projector to die a couple times. Okay, I saw the right number there. All right, now I want to look at source IP field. So here's suricata alerts detecting something it thought was significant. So if I look at source IP, it's here. And this is the source IP of that Web 8105 desktop, the one I'm worried about. So I restrict to just that one. And now I look at the event type field. Going to be down here somewhere. Okay. Here's various types of events. And what I want are HTTP events because I'm looking for, I think that my belief is this guy went to a website and got infected. That was we did something suspicious on a website. So I want to see what websites that person was visiting on the day of the ransomware outbreak. And if you look at the host names visited, one of them is obviously malicious. So it might be called host name and it might be called HTTP host name. Here it is, HTTP host name. There you go. So Microsoft Bing, this is the one, solidarityproximity.org. That's a goofy one. And if you don't believe that's malicious, you can Google it, and it's a known malicious domain. If you just go to Google and Google that domain name, it should come up in here it is, Anatomy of Ransomware Tracks Cerber Use, saying they downloaded it from here, and there's the name of the thing that comes down. And if you read this article, you learn about how Cerber actually used steganography, and it hid script in that image. And if you go on with the other challenges, you'll actually find the Visual Basic script, and you can analyze it and see how it ran. So it's good practice using Splunk. Anyway, I think that's enough for a demo for today. That's been about an hour. I'm going to stop the recording.